All right, so problem 6. Football kicker lines up to kick a game-winning kick. The goalpost is 30 meters away. The ball must clear the 3.3 meter high crossbar. If the kick leaves his foot at an angle of 35 degrees, how fast must the kick be to be good? Okay. So we got a football player kicking the ball. Okay, there he is. And the goalpost right here, let's say. All right. So that would be the goalpost. And the ball has to clear this 3.3 meter post in order to be good. So that's 3.3 meters there. Okay. So we've got our displacement vector, looks like that. Okay. The kick looks like this. I can fix that, make that a little better. Okay. Let's see. All right. And this is our, so we don't know our initial velocity, I'm guessing. We know our horizontal displacement. We know our minimum possible vertical displacement. So I'm going to find like the minimum speed necessary to make this happen. Okay. So the goalpost is 30 meters away. That's my delta x, right? And my delta y is going to be 3.3 meters. Sorry. This vector up here is 1/2 a, which is 5. So a is 10 meters per second squared. So 5 t squared. I don't know t. And my initial velocity, I don't know. Nor do I know t. But I know that this angle here is looks like 40 degrees for that angle. So see what I can figure out. Let's go with sine. So sine 40 degrees has to equal my 3.3 meters plus my 5t squared. So the only thing I don't know in that equation is t. Let's see what I can, over v naught t. So there's two variables I don't know in this equation. So there's not much I could do there. So let's use cosine. All right. So cosine theta is going to be cosine of 40 degrees. So not theta, cosine of 40 degrees. Cosine 40 degrees is going to be 30 over v naught t. And so that means that v naught t is going to be 30 over cosine 40. All right. So let's take this and put it here. Okay. So I got sine 40 degrees has to equal 3.3 plus 5 t squared over 30 over cosine 40 degrees. So I can multiply by cosine 40 degrees over 30, cosine 40 degrees over 30. That gets rid of this. So sine 40 degrees equals 3.3 plus 5t squared. And this is all that just times cosine 40. And all of that is divided by 30. Okay? So this is 30 sine 40 degrees equals 3.3 plus 5t squared cosine 40 degrees. Alright, so I think I'll be better off if I divide both sides by cosine 40. So this is over cosine 40. And this is the same thing as 30 tangent 40 degrees. 3.3 plus 5t squared. See what would be good now. Let's take away 3.3 from both sides. So I get 30 tangent 40 degrees minus 3.3 equals 5t squared. Okay, divide both sides by 5. So I get t squared equals 30 over 5 is 6, right? So this is 6 tangent 40 degrees minus 3.3, right? So, well, let's see. So t is going to be square root of 6 tangent 40 degrees minus 3.3. So let's see what we get here. 40 degrees. Where's tangent? There's tangent. Tangent 40 degrees times 6 equals minus 3.3 equals square root. I get t is 1.3. So t is about 1.3 seconds. Now that I know that, I could find this side here. So I square t, I multiply by 5, I get 8.7. So this is about 8.7. Okay. I add my 8.7 plus 3.3. That means this side is about 12 right here. So this entire side from top to bottom is about 12 meters. Okay. So I can use Pythagorean theorem to find V naught t pretty easily. So let's do that. So V naught t is going to be square root of 30 squared plus 12 squared, right? So V naught t, so V naught, that means V naught is going to be all that divided by t, where t is 1.3. So this is all divided by 1.3. So that means V naught so I got 30. Let me clear my memory. Okay, 30 memory plus 12 memory plus. So square root of all that, divide by 1.3, and that's 24.8, 24.9. So my initial velocity has to be about 24.9 meters per second in order to just barely clear the goalpost. Anyway, that's a pretty cool problem. Hope you enjoyed it, and thanks for watching. Have a good night.